So guys, our today's topic is a Bode plot. The example is given as the unity feedback control system as G of S is 100 upon S into S plus 0.5 into S plus 10. Here we have to plot the Bode plot and also determine gain margin, phase margin, gain crossover frequency and phase crossover frequency. This example is also asked in the examination for the 10 marks. So don't waste your marks. It is very easy. So see, first of all, the example is given as G of S 100 upon S into S plus 0.5 into S plus 10. So first of all, we have to write it is into standard form. So it is in the time domain. So it is in time domain. So write it is in the proper way. 0.5 and 10. Take the outside because our standard equation is 1 upon 0.5 something the value upon j omega. This value will becomes that's the value. So S upon 0.5 into here we have taken the 10 is outside. So 1 into it is a yes upon how much 10. See 100 into 0.5 into 10. So how much it is a 5 by 100 yes to 1 plus yes upon 0.5 into 1 plus yes upon 10. So this is a how much 100 upon 50 100 upon 5 sorry this is a 20 5 upon yes into 1 plus yes upon 0.5 into 1 plus yes upon 10. So see, this is the value of k. So k is equals to how much? K equals to 20 log 10 to the base of k means this is a 20 log 10 to the base of 10 means k is 20 here. So 20. So first you take it to calci 20 log 10 to the base of 20. The value becomes the 26.02. This is the value. So first then it is in the time domain. So now we have to convert it. The value is given here. We are getting the standard equation in the time domain. So we have to convert it in the frequency domain. So for the frequency domain, we have to replace S is replaced by the j omega. So this is a now this becomes a k. K means it 26.02 means you have to write k j omega into sorry it is 1 suppose 1 plus j omega upon 0.5 into 1 plus yes upon j omega upon 10. So see, don't waste the time for that draw sub values and some things and do some things. See, in this video we have the getting the we are getting the here how much is the zeros. It is a zeros. The zeros is present at the numerator and poles is present at the denominator. How much poles is present? 1, 2 and 3. So first of all make the table. This is my poles. The poles is every pole is the pole is at the origin which is decaying by minus 20 dB per decade each pole. So the poles which are decaying by minus pole something values it depends on that. So my pole is 1 upon j omega. 1 upon j omega is my first pole means my value is decaying minus 20 dB per decade. See, if the pole is present at the denominator, each value is decaying by the minus 20 dB per decade. If the poles will be present at the zeros, suppose if the 0 is present, so it is how much decaying? It is decaying by plus 20 dB per decade. But here no 0 is present. That's why we are taking the minus 20 dB per decade for that one. Then second one is for but the range. Now we have to take in the range. So range is how much? Range is from 0 to 0.5. 0 omega is less than equal to 0.5. My pole is decaying by how much? Minus 20 dB per decade. The second pole is 1 plus j omega upon 0.5. So this is a minus 20 dB per decade. First pole is decaying by how much? Minus 20 dB per decade. And Second pole is decaying by how much? Minus 20 dB per decade. Once again. So my result is now how much? Minus 40 dB per decade. Means my pole 1 upon G1 plus 1 plus J omega upon 0.5 is decaying by how much? Minus 40 dB per decade. The range is from my 0.5. See, the range is between the, see, this is a first range, means it is a pole is at the 0, means S plus 0, means 0 to 0.5 is the first range. So second range is from 0.5 to 10. So this is a range from 0.5 is less than equal to omega is less than equal to 10. Now my third pole is